Good morning and welcome to today's lesson on solving inequalities. Okay, now, first of all, let's talk about what I mean when I say an inequality. Okay, there are four types of inequalities. Okay, there's the less than, and I always think it looks kind of like an L that's been squished, so it always makes it easier. Okay, there's greater than. Okay, and I know many of you remember back in elementary school that you just, hey, the alligator wants to eat the bigger number, but it's kind of important to know which one means what. So if you're reading a word problem or someone is saying it out loud, hey, this is greater than that or this is less than that, you should know which one is which. Okay, the next one would be with this line underneath it, and that's the less than or equal to. And then the same thing is true if I put the line under this one, which is it becomes the greater than or equal to. So those are the four types of inequalities. And there's other ways to describe them, and I'm going to talk a tiny bit about them. I may throw a couple of extra sort of vocabulary at you. In fact, why don't I do that right now? This one, the less than or equal to, could also be called at most, meaning the most it can be is that. So, right, if I tell you, like, what's a good example of an at most? If you've ever been to an amusement park like Disneyland and tried to go on the really, really little kiddie rides, they sometimes tell you you can't be taller than this because your head would get knocked off. So at most, your height can be this. That's what it's telling you, is it's less than or equal to. This is the line, got to be lower than that. And then the same thing I just said right there is at least. That one I'm sure you've seen if you've gone to an amusement park, right? You must be at least as tall as this sign to go on the ride. This tall or taller, or you can't go on the ride, okay? So that's what it means when it talks about, now it's really, so greater than or at least, at most, less than, or equal to, okay? The difference though is when to know if it's an equal to or when it's not an equal to, okay? And it just depends on the context. A lot of these kinds of problems are in reference to comparing two things, okay? That's larger than this. That's greater than that. That's less than that. And oftentimes, what really kicks in here is perspective. Which side are you describing from? Okay, I could say, I am older than you. Okay, that would be I'm greater than in age than you are. But what if I wanted to describe the same thing in reverse? I could say you are less than in age, you are younger than I am. It's the same information, right? Alligator still wants to eat the bigger number, that'd be me, because I'm the older one here. But either way, it's being described as from the perspective of whichever one I want to talk about it from. Now, this is why I talked in the last one about solving equations where you want to get the variable on the left. Because when we solve inequalities, we really want to have that variable on the left. Because most of the time, we read from left to right. So I want to say this is I am older than you. You are younger than I am. Okay? But I know this sounds weird to say, I could read it backwards. Because that's really what I'm doing, right? If I say I am older than you, I would say you are younger than I am. See? That's how it ends up being written. So the description oftentimes dictates what number is on the left and what number is on the right, and or if there's a variable in one situation. I'm looking for all the numbers that are greater than 5. I'm looking for all the numbers that are smaller than 3. Okay? So those are the kinds of things that we're looking for. Okay? So those are the inequalities that I will be describing to you. Now, but we're not just talking about inequalities, we're actually going to be solving them. Now, here's my question to you. Is there a difference when solving inequalities as opposed to equations? So we've just spent all this time learning how to solve an equation. Equations have equal signs. Inequalities have those symbols that I just showed you, the at most, the at least, the greater than, the less than, greater than or equal to, less than or equal to. Is there a difference between solving an inequality versus solving an equation? Okay? So the answer is sort of a yes or no. Yes and no. We use the inverse order. So in fact, it's going to be parentheses, it's going to be combining like terms, it's going to be get the variable, and this time we're going to say it on the left, every time. Then we're going to have our subtraction, our addition, our division, and our multiplication. Okay, we're not going to be dealing with exponents. Okay, but we could. It still falls in the same spot. So the order in which we do things has not changed. Okay? Order has not changed. So you'd think, so for the most part, you're going to be solving these exactly the same way you would be solving them if they were equations. We're going to do the same things in the same order every time. Now, when we're doing these, we're actually going to go through very, very simple problems. We are not going to get anywhere near the five-steppers that we just finished doing with equations. And the reason why is because there's no point. If you know how to solve a five-step equation, you know how to solve a five-step inequality. It's not different. The order is not different. The what to do, the when to do it, the numbers that do not change. There is one difference between solving an equation and solving an inequality, and we're going to talk about that in just a minute. Okay? But for the most part, nothing is different. The order is the same, the steps are the same, when to do them is the same, everything about it is the same. Okay? So, what is the one difference? Well, let's solve a few, and we'll come to, we're going to solve a couple of really, really quick ones, okay? We're going to start with, how about just a one-stepper? How about x plus 3 is greater than 2? Seems pretty straightforward. There's no parentheses, there's no like terms, the variable is already on the left. I've got some addition, so I'm going to subtract, and boom, I'm done. X is greater than -1. X, so let me talk about what this solution means too. Because you don't just say x is greater than -1. It's not quite enough. X now represents all the numbers that are greater than -1. Now, it's not enough for you to just tell me that x is 5, because yes, 5 is greater than -1. You need to tell me x represents all the possible numbers. So now there's an infinite number of right answers. Because I could ask everybody in this room to pick a number greater than -1, and you could all pick different numbers. Someone could pick 2 and 5 and 6 and 12 and 1,000,000,000.1, and everybody could pick different numbers because x represents all of them. So you need to include that in your descriptor, and we're going to see how that plays out when we get into graphing inequalities, which will be our next lesson. So when solving, we need to know, what does the solution represent? It represents that x now represents all the numbers that are greater than -1. Same is true if we did a subtraction. If we had x minus 4 is less than or equal to 2, I would go through the same, no parentheses, no like terms, variables are already on one side, there is some subtraction, so I'm adding, and I get x is less than or equal to 6. So all the numbers that are less than or equal to 6. So 6, 5, 4, 3, 2, 1, and so on. And decimal values, it could be 5.1. could be 1.3, negative 1/2. Who knows? Okay? Nothing has changed. So let's get to the one where something does change. Okay? 2x is greater, you know what, I'm going to give myself some more room. We're going to go right up back to the top here and say, how about 2x is less than 6? Just going to make it real easy. Because the arithmetic's not what the problem is. The problem is knowing what's different. Well, again, no parentheses, no like terms, got the variables, no subtraction, no addition. I need to divide, so I'm going to divide by 2. And you know what? Nothing changed. Nothing at all. So here comes when it does change. And I know what you're thinking. You're immediately thinking it's division. Nope. Division and multiplication are the same thing. What depends is the coefficient. The number in front of the x when it's negative. I'm still doing the same step. I'm dividing both sides by the number next to the variable, which in this case is a -2. Positive 6 divided by -2 is -3. Here's the time when it changes. This turns around to face the other direction. The alligator now wants to eat the other number. So while this one came out as all the numbers less than 3, this one came out as all the numbers greater than -3. Because so here we go. When you multiply or divide by a negative number, you must turn the inequality sign around. You must turn it to face the other direction. So it is not enough to just do the division. You actually have to do something to the inequality sign. Now, you would never change one that has a line under it to one that doesn't, but you could flip it to face the other way. And I'm going to give you kind of a simple reason why, but I'm going to give you a second to process this. So let me say it one more time. Whenever you multiply or divide by a negative number, you always turn the inequality sign to face the other direction. You turn it around. You change what the alligator wants to eat. Okay? So let me give you an example with just very simple numbers that kind of makes this make sense. Okay? You have $2, you have $3. I ask a small child, which one would you rather have? Which one would the alligator like to eat? And you say, well, the alligator wants to eat the $3 because 3 is greater than 2. Or you could say 2 is less than 3. Right? That's pretty straightforward. We know it's true. It's nothing special there, nothing challenging. But what happens when I multiply both sides by -1? Well, a positive times a negative becomes a negative, and a positive times a negative is still a negative. And now I ask you this question: which would you rather? So I asked you here, would you rather have $2 or would you rather have $3? And you told me you'd rather have 3. Now I ask you, which would you rather? Would you rather owe $2 or would you rather owe $3? Well, I'd rather owe 2 than 3 because I don't like owing money. I don't like being in debt. I like having money. So I don't want to owe the $3. I want to owe the $2. So by doing this simple operation, I've changed basically what we're talking about from having money to owing money. And the evaluation process changes. And if you think about how this looks on a number line, here's 2, here's 3. Further to the right is bigger, right? We know that. This is 0, 1, 2, 3. I could go on, 4, 5, right? The bigger numbers are to the right. Well, and as such, the smaller numbers are to the left. Well, -2 is further to the right than -3, and therefore it is the larger number. So when it kind of flip-flops, they change. Okay? So, when adding, subtracting, never changes. When multiplying or dividing, it changes only if you are multiplying or dividing by a negative number. So I need to show you one more just to make clear the difference. Okay, I'm going to show them side by side. Okay, -2x is less than 6. 2x is less than -6. A lot of students would think these would end up being the same, and they very much are not. Because on the left-hand side, we're dividing by -2. When we divide by -2, we have to turn the inequality sign around. On the right-hand side, we're dividing by 2. When we divide by 2, we do not have to turn the inequality sign around. The active number, the number that's doing the operation, determines if the sign must change. So it's only if this number right here is the number that tells us, the number that's next to the x, that's the number that tells us whether we're going to be turning the inequality sign around or not. If it's negative, we are going to be turning it around. If it is not negative, this number doesn't make a dang bit of difference. Okay, it's the active number, it's the number that is performing the operation that determines whether we will be turning the sign around. And again, show your work. I know everybody in this room can do 6 divided by -2 in your head, but show me that that's what you're doing. Show me this. If you go from this to this, I can't give you credit. Okay, I'm sorry, but not really. Show me your work. All right. That is it for today, and I will see you in class or in office hours.